prefabrication was about improving the quality of construction. We think there's a growing opportunity for higher efficiency in the amount of time, a higher efficiency in the use of construction dollars, and we think much higher level of quality in construction.
I think the definition of prefabrication is also changing as BIM tools become more and more sophisticated, and they give us a more comprehensive understanding of the way the building is assembled virtually before the actual construction. And that adds great efficiency to the construction process. Prefabrication is one extension of that. You can begin to look at all these systems simultaneously. You can begin to think about large spaces in the building more like very sophisticated components and not things that would have to be built in an ad hoc way on site. And that understanding of componentry and the systems approach then dovetails really nicely into what you can do in prefabrication.
We thought through what we need to do to actually get this off the ground. The first was making sure that our design and construction partners were embracing this as enthusiastically as we were. We also knew that we didn't want prefabrication to drive any of the design decisions, so we made sure that we made the right design decisions, right from an aesthetic standpoint and also from a functional standpoint, before we applied the lens of prefabrication to the work. And then we looked at what systems within the building are flexible, repetitive, and fairly easy to work into some module. So through the course of the project, we identified 5 initiatives. Unitizing the exterior curtain wall, which is not something that's new, certainly, but we'd like to think something we have taken the next step on this project. Modular demountable caregiver workstations throughout the inpatient corridor, a temporary bridge, the inpatient room, and integrated MEP rack. So unitized curtain wall is, again, not a new concept, although it's something that probably is, at least for MBBJ, only been around for 5 years. And when you think about it, it just makes a lot of sense. You know, instead of hanging up each individual stick of aluminum and each individual piece of insulated glass and glazing it outside in the environment, hanging over the edge of a building or right on the edge, the inboard side of the building, designing in a way where the exterior wall system can be modular still looks like it's fairly random. You know, the opportunities are endless. It certainly does increase the speed to which you get the building enclosed, which is very important. Particularly in a project site like Miami Valley Hospital, where it's a very tight urban site, you don't have a lot of laydown area. You're not having all this stuff laying around. You're actually shipping units. In order to build the 500,000 square foot project on the site, 3 buildings had to come down. In addition to the buildings needing to be demoed, a very important circulation path ran through 2 of the buildings that were connected by overhead walkways. In order to take the buildings down, but not interrupt the flow of that traffic, we had to come up with some type of bypass, which you can see in yellow here. And it was temporary because that bypass is now becoming the new main entry drop-off for the hospital, not just for the new addition, but for the entire campus. But that bypass was being priced at about, I think, $2.1 million. And because that hairpin turn at the top was the existing drop-off for the hospital, it could disrupt traffic flow for anywhere between 4 to 6 months. So we thought, well, what companies are out there that make elevated walkways? So we contacted a jetway company. I think actually Skanska made the connection with FMC, asked them if they were up for it. They hadn't done anything in this type of application before, but they said, yeah, we'll give it a shot. So the process started of them producing drawings for us to review, and the structure was in place. You can see it there behind the wooden fence. On December 12th, with the structure in place, by the next day, about a third of the bridge was installed. Each of the following 2 days, the entire bridge was in place, and you can see that the first building is being raised there behind. This piece of the case study does have some tangible metrics for us to look at. We're comparing over $2 million of construction with $980,000 of construction, comparing what would have been a very messy 4 to 6 months of disruption of their main entry to 3 days to install that bridge and absolutely no disruption at all because the thing was hoisted from the site side, and I don't think they had a single hour of traffic interruption. And then comparing at $2.1 million completely being discarded, not having any use for it. With the prefabricated model, since it is in a unit, we're able to use about, I think it's actually now about a half of it, somewhere else on site in a permanent location.
On this project, the meeting with the hospital administrators and the users always reinforced the theme of standardization and flexibility. So what we ended up with was a bed tower that's designed to contain 180 patient rooms, and then has 2 additional floors above that are shelf space, and those would later contain another 72 patient rooms. In the right corner of the screen, you see a typical patient floor, and there are 3 wings per floor that has a patient bed, 12 beds per wing, and the rooms themselves are same-handed as opposed to a conventional deployment of rooms that has them mirrored, so they would share head walls. And with 180 identical rooms, there was an intuitive thinking about the prefabricated efficiency or economies that might come if we could build these in a factory, build them off-site. But the room itself is a very large object. It's 16 feet wide and 22 feet deep, and so a very obvious question, is just one of logistics. You could build these off-site, but how would you ship them? How would you get them across the highway? How would you elevate them and lift them up into the waiting bed tower? And the breakthrough for the team was realizing that because of the way we had done a same-handed room, we wouldn't necessarily have to prefabricate the 300 square foot face of a room, but we could just prefabricate the blade, the demising wall that separates one room from another room. Because in that blade, you actually have compressed all the complexity of one patient's head wall and one patient toilet room, and then the adjacent patient rooms, foot wall and family media center, caregiver station, and hand washing sink. And so a delivery diagram, or a conceptual way of thinking about the way you could move forward on the project, would be one that prefabricates 180 of these blades, then deploys them on site, and instantly generates 180 rooms. Knowing all along that we might not build them as one piece per blade, but it might be smarter to break that into smaller pieces, and you see that it's been divided into 3 pieces. The first is the toilet room module, the second is the head wall module, and then the third is the casework module. Then we can jump right into the fab shop where they were building all of these things. Here you see basically a field of the toilet room module being constructed, and then down a floor level looking into 2 of the rooms. And then again, if you walk around the back, you see all the infrastructural support for what would be the patient room adjacent to this one. Moving to site deployment, there were 3 of them that would fit onto one flatbed truck, and here you see one of them being lifted off. Here you see the toilet room module being flown up to its floor. In this next shot, you see its reception into the floor right in the middle of the slide. When they're brought in, they are landed on top of a small custom-made truck. That allows them to slide these to their desired location on the floor. And then the floor was poured with a slab depression that's designed to receive the 5-sided shape of the module itself. The fact that from a medical planning effort, there's a line of inquiry that is exploring the efficiencies, the potential patient safety advantages of a same-handed patient room. And then there's another side of our practice that is exploring the efficiencies of prefabrication. It's really nice to think about this patient room as the convergence of those 2 lines of inquiry, especially when you think about the fact that the same-handed patient room usually has a cost premium associated with it, that the room itself costs more than a conventional mirrored room, but that cost could be offset by the fact that it is more apt to be prefabricated. So those 2 lines of inquiry intersect at the patient room, and the savings that you get from one line of inquiry can then offset or even make viable financially the premium that you would pay for the other. It's that kind of multidisciplinary thinking that I think we can be really proud of on this project. And then we can jump to the integrated MEP rack prefabrication initiative. Again, that shot of the typical patient wing. We have a 16-foot wide corridor that runs through the center of that wing, and a lot of stuff in the ceiling of that corridor. Heating, ventilation, air conditioning ducts and control boxes, gas plumbing and sprinkler lines, and electrical and wiring trays. So a question was, how could we load all of the complexity of those systems into something that could be prefabricated, built off-site, and delivered? The approach was to divide that 16-foot wide corridor that runs through the center of this slide into a series of 8 by 20-foot racks. These racks would be built of steel unistrut off-site, and all the systems that I had mentioned before would be loaded into those racks. So here's a shot of the model of one of those racks. You see basically a steel frame and then a lot of piping and ductwork that's loaded in. And then we can go right to the photos of the shop floor. So you're looking at steel framing, all the systems that run through the middle of that steel framing, and then on the end, on the far left side of the screen, you see a smoke-tight partition that actually completes the corridor wall above ceiling and forms a smoke-tight partition between the corridor and the adjacent patient room. In this shot, 10 racks per wing, they're all pushed together as they would be in a typical wing, but when they're building them, they can be pulled apart. Because they were built as separate pieces, but then need to all be unified and connected on site, basically every system that crosses from rack to rack needed its own quick coupling device, and in this case, the approach was a 1-foot section of flexible pipe that's left loose while they're built off-site and then is connected when they are installed on-site. Here's the bolt that allows the metal rack, the frame itself, to be hung from the structural deck above. This photo you see two of the workers in the shop who are working out some of the penetrations through that smoke-tight partition. If this was built conventionally, these guys would be standing on ladders, and the tools that they're using, they'd be using those tools above their heads. So the fact that they are standing on the floor rather than standing on ladders, and that this work platform allows them to work at a much more comfortable and ergonomic position. So in a lot of projects of the last few years, we've talked about the health and well-being of the people who work in our building, but then with this approach, we're beginning to get into something we're really excited about. That would be the health and well-being of the people who are working on our projects as well. Then 2 racks were basically fitted per flatbed truck, and you see the rack on the left just being lifted off, the crane work to get those up to their floors. Then here, that rack being received by the guys at the appropriate floor, and then the racks being suspended from the deck. And then here, basically a shot of the patient room demising walls, which you see on the floor, and the racks above. Everything you see in this photo, with the exception of the steel structure, is a part of the prefabrication process.